Hey everyone, today we're diving into something that we all have to do, but maybe not as well as we could, and that's solving problems. We're going to move way beyond just plugging numbers into a formula and really explore a powerful framework for thinking through a challenge. So, let's get right into it.
You know that feeling, don't you? You read the question, you see all the numbers, you might even remember the right equation, but you're just stuck. It's so frustrating, and it usually happens when we know the steps, but we don't really understand the process.
And this right here is the heart of the problem. So many of us were taught to just fill in the blanks for step 1, step 2, and step 3 to get a good grade. We treat it like a boring checklist. But the real magic happens when we start using these steps to actually guide our thinking, not just to label our work after we're already done. So let's rebuild that foundation. We're going to walk through a 3-step approach that can turn problem solving from a confusing mess into a clear, totally manageable process. And to make it real, we'll use a simple physics problem to show you how it works. Okay, here's our setup. We've got 2 cars, car A and car B, and they're both heading for the same intersection. Car A is just cruising at a staid speed. Car B, on the other hand, is speeding up from a dead stop. They start at different distances, but at the exact same time. The big question is, do they crash? And this brings us to our first, and I would argue most crucial step. Understand the problem. Seriously, the goal here is not to start doing math. Not yet. It's about slowing down, getting your bearings, and building a really solid mental map before you even think about calculating anything.
And to really nail this understanding part, we can break it down into 3 smaller, super practical actions. We're going to sketch it out, we're going to list what we know and what we don't, and then we're going to simplify it all into a solvable model.
First things first, get the problem out of your head and onto paper. A simple drawing of the roads, the junction, the cars, it might seem almost childishly simple, but it is so essential. It just gets rid of any confusion and frees up a ton of mental energy. You don't have to keep picturing the whole scene in your head anymore, which lets your brain focus on, actually thinking.
Now, here's what's really cool. We can also sketch the problem in a totally different way to build our intuition. A quick little graph of distance versus time. For car A, with its constant speed, that's just a straight line. For car B, which is accelerating, it's a curve. We don't even need exact numbers yet. This visual just helps us feel the difference in how they're moving. It gets us asking the right questions.
Next up, we organize all the information. Just dropping the knowns and unknowns into a simple table like this gives you instant clarity. It makes sure you haven't missed any key details, and it perfectly frames what we're actually trying to find, the time it takes for each car to get to that junction.
And finally, we model the problem. Look, the real world is messy. To make this problem solvable, we have to make some simplifying assumptions. We're going to assume the roads are perfectly straight, there's no traffic, and we're treating these big cars as tiny little points. This isn't about ignoring reality. It's about building a bridge from a complicated situation to a clean, core problem we can actually work with. Okay, now that we actually understand the problem inside and out, we can move to step 2, devise a strategy. This is that moment of pause. It is by far the step most people skip. They just jump right into the calculations. But this is the step that makes sure you're heading in the right direction and not just wasting your time.
I think this quote just nails it. Your strategy is the map. Without a map, you're just wandering around in a forest of equations, hoping you stumble across the right answer. A good strategy makes your solution focused, intentional, and way more efficient.
So, what does a strategy look like here? Well, it starts with picking the right tools for the job. We start with a general equation of motion. Then, for car A, which has 0 acceleration, it simplifies way down. And for car B, which starts from rest, it simplifies too. Notice what we're doing. We are not plugging in any numbers yet. We're just selecting and sharpening our tools before we start building.
And here it is, our plan of attack. It's simple, it's sequential. 1. Find the time for car A. 2. Find the time for car B. 3. Compare them. Writing this down, even for a problem that seems pretty easy, builds an incredibly powerful habit. It stops you from just diving headfirst into a bunch of algebra with no clear goal.
All right, now we are finally ready for step 3, solve and verify. This is the part everybody recognizes, right? But it is so much more than just plugging in numbers. It's about executing your plan carefully and then, and this is critical, checking to see if your answer even makes sense. Okay, following our plan for car A, we've got 600 meters divided by a constant speed of 20 meters per second. The math is pretty straightforward. And boom,
Car A gets to the junction in exactly 30 seconds.
Now for car B. We use our simplified equation for acceleration, calculate its time to travel 800 meters, and it gets there in 28.28 seconds. So we've got our two numbers.
And this is it, the moment of truth. Car A shows up at 30 seconds. Car B gets there at 28.28 seconds. So what does that mean for our big question? The answer is no, they don't collide. Car B gets to that intersection first, and it clears out of the way just under 2 seconds before Car A even arrives. So in our simplified model, crisis averted. But wait, we are not quite done. The final, crucial move is to verify. First, we check our units, meters, seconds. Yep, everything lines up. Next, a logic check. We kind of expected the accelerating car to be pretty fast, right? So the result fits the intuition we built from our sketch. And finally, a little reality check. In the real world, 1.72 seconds is a dangerously close call. This final step is what separates just doing calculations from true understanding.
And that really brings us to the main takeaway here. The number 1.72 seconds is the answer to the math problem, but the process we just walked through, that's the real solution. The goal was never just about getting a number. It was about the insight and the clarity we built at every single step.
This really just gets right to the heart of it all. When you solve a problem with intention, by understanding it, building a strategy, and then thoughtfully executing and verifying, it stops being a chore. It becomes this dynamic act of understanding.
So I'll leave you with this question to think about. Whether it's a math problem, a challenge at work, or even a personal dilemma, think about this 3-step framework. What problem in your life could benefit from you taking a moment to really, truly understand it before you jump in and try to solve it? Thanks for joining me for this explainer.